It's a front-end client framework for doing component-based web applications. It's very, very early in the process. It started as essentially a demo for a talk by one of the folks on the ASP.NET team last fall. And his talk went so well, everyone was so blown away by what this guy had built, that the ASP.NET team decided to try and see if they could turn it into a real product. So right now it's kind of in an incubation stage where they're playing around with it, getting some feedback from the community. They've called it an experiment, so it's not committed to be a product yet. That's important because you don't want to go back and rewrite your whole app in Blazor tomorrow. There's a good chance it might get discontinued. There's an even better chance, I think, though, that it will continue on and become a product at some point, given how much momentum and interest there is around this. But all that said, it's under very active development and it's changing constantly. I actually put the slides and code together for this talk about 2 weeks ago. Last week they released version 0.2 from version 0.1, and I had to rewrite everything because it was so different. And that's kind of where they're at right now, is a lot of churn as they figure out what people want and how it should work. So first, let's talk about what Blazor is. And we're going to need to talk about some other fundamental technologies before we get to Blazor itself. And that's important because Blazor uses a lot of other things like WebAssembly, Mono, Razor. So I want to make sure we cover that before talking about Blazor, because if we don't, it's not going to be totally obvious what it is that we're talking about once we start looking at the code and what you can and can't do with it. So here, this is right from the Blazor website here. Experimental .NET web framework using C# and Razor and HTML that runs in the browser with WebAssembly. So there's a lot of buzzwords in there. Razor, everyone familiar with Razor? Anyone not familiar with Razor? Razor is the templating language that ASP.NET MVC uses. More recently, it's also the templating language that they've created a new web framework called Razor Pages from. That's important because Blazor is more related to Razor Pages than it is ASP.NET MVC. The idea with Razor Pages, if you're not familiar with that, is it's essentially the view part of ASP.NET MVC with Razor templates, but without the C part. There's no controller. All of your controller code sits directly in the view as blocks of C#. And you'll see when we get to the Blazor components that it follows that same convention. There is no back-end controller. It's entirely on the client. So all of your code has to go in the browser, similar to how you would write blocks of JavaScript. Now this can get a little confusing because whereas Razor Pages in ASP.NET MVC execute on the server, and so you have access to, if you call an IO method, you're accessing the server's resources, right? The hard drive or the memory or whatever on the server. The same code, when you run it in Blazor, is executing on the client. So it looks very similar, but the place that you're executing that code is different. And so that can trip you up if you start getting confused about where things are executing. They're working on sort of doing Blazor in two different modes. One is entirely on the client, similar to what React or Angular or Vue would do. The other mode is to tie in tightly with back-end code from, say, a controller using ASP.NET, where the client-side pieces of Blazor talk to controllers on your server. I'm only going to cover the former right now. The story for the latter isn't really fleshed out too well yet, so they're kind of still figuring out what that looks like. The promise is that you may query a database, you get back say a sequence of entities or something from Entity Framework, and then you feed that to your client, and it all just works. You say, hey, here's a list of products. And the client, because it's also using C#, gets the list of products. You don't have to think about serialize into JSON. You don't have to think about how that works across the wire. It just ends up on your client, and the code works the way you would think. That's sort of where they're aiming for that second model. So here's some places to look at. Here's where the repository lives in ASP.NET/Blazor on GitHub. It's all open, all being done open source. You can see the issues. If you end up, after this talk, wanting to learn more, the best place to learn more is from the issues in that repository. There's a bunch of question issues that have really good information where the team has responded back to people's queries. And even just looking through the PRs that they're sending to themselves. What changed? What did they do to change this? How does this work? What kind of features are they introducing? All of that is valuable to learn. So let's talk about WebAssembly, because none of this would be possible without WebAssembly. WebAssembly is a technology that lets you execute arbitrary, essentially pre-compiled programs in your browser. And the idea is it acts kind of like a Java JVM or the .NET CLR. It's essentially a runtime that can execute intermediate code that will run that code in your browser. So Rust, C++, Java, Go, all these languages are currently experimenting with different ways of using WebAssembly in order to let you program in those languages in the browser. The good news is that it was experimental for a long time. It wasn't widely available. All the major browsers now support WebAssembly. So what does Blazor look like? How does Blazor use WebAssembly? The way this works, Mono is an alternate .NET runtime that's been around forever. It powers the Xamarin line of products. If you're writing .NET and deploying to, say, iOS, Android, other platforms, for a while, Mono was the only way to run .NET on Linux or OS X boxes. Mono is essentially a highly portable version of the .NET CLR. It started out being totally reverse engineered because it's been around longer than .NET has been open source. So the Mono team, about a year and a half ago, as WebAssembly was becoming interesting and popular, decided that they were going to see if they could get the Mono.NET runtime to run in the browser on WebAssembly. And remember I said languages like C, C++ have already been experimenting with WebAssembly. So what the Mono team tried to do, and has done successfully, is take the Mono.NET runtime, which is all written in C, and compile that to WebAssembly. So now the Mono runtime runs in the browser. And we'll get a little bit more of what that means in a minute. In addition, that runtime includes the IL interpreter, IL being intermediate language. When you compile a .NET application, what you end up with in that DLL is something called IL. It's essentially machine code, but at a slightly higher level. So the Mono runtime that they've compiled to WebAssembly knows how to read and evaluate the IL code that's in .NET assemblies. That's important, and we'll get to that a little bit later too. Blazor files are essentially .NET assemblies. They're just normal assemblies. If you opened one in a decompiler on your system after compiling it and before deploying it to the web, you'd be able to see methods, classes. It's just normal .NET code. And the templates in Blazor I mentioned are based on Razor pages. OK, so before we go any further into Blazor, let's build up a little bit and first look at exactly how JavaScript works. And this is important because it's going to help inform the limitations that Blazor is going to have by working on WebAssembly. And it's important to understand those limitations. So when you have a either inline JavaScript in a script tag or an actual JavaScript file, when your browser loads that, what happens to it? Well, it goes to something called JavaScript runtime or JavaScript engine. And generally, these consist of 3 different parts. This is a gross oversimplification, by the way. Modern JavaScript engines are way more complicated. They do all kinds of fancy caching and iteration and look ahead and all kinds of things to make your JavaScript really, really fast. But this is essentially what's going on. This JavaScript code is fed to a parser. The parser is responsible for basically tokenizing that code, figuring out what it means, separating it into sections that it can then reason about. That's basically just string manipulation. It looks at the code you fed it and splits it up into smaller strings. All of that information gets fed to a compiler, which takes the tokenized syntax tree that the parser has created and essentially converts it into something like an IL, basically a bytecode. And if you're all familiar with the Java world, Java runs on bytecode. JavaScript bytecode is not the same as Java bytecode, but it's similar. So this compiler turns it into bytecode, which the just-in-time, the jitter, reads and evaluates as it reaches each instruction. So as your JavaScript code evaluates and it goes from line to line, the jitter is going to take that line of code, and as you get to that line, it's going to figure out what it means and execute those instructions. Like I said, this is not really what happens anymore. The jitters have all kinds of look ahead, so they're pre-compiling stuff in the background. But generally, this is going to evaluate your code on the fly. It's very similar to what .NET does, right? In .NET, we have Roslyn, which is essentially a parser and compiler that converts our .NET code into IL or an assembly. And then we have a jitter, the CLR, which takes that IL and executes it on your machine. So the Java runtime is very similar to .NET. It's very similar to Java in the JVM. Now this jitter can talk to web APIs like the DOM, like file storage. And that can only happen through here. The web APIs aren't actually part of the JavaScript language. They're part of an API set that's sort of invisibly presented to your JavaScript code that the jitter knows how to bind to at runtime. That's really important when we get into Blazor, and we'll get there. Okay, so let's add WebAssembly to this mix. What does WebAssembly do? Remember I said WebAssembly lets you compile anything you want into bytecode, basically. So what WebAssembly does is it lets you short circuit this stage and go straight to the JavaScript jitter inside of these JavaScript engines in your browser. Why is that important? Because if you're going straight to bytecode and into the just-in-time engine, we don't have to have JavaScript anymore. We just have to have the bytecode. So any language can target WebAssembly, which is then read by the JavaScript engine that's already in your browser and can interact with web APIs like the DOM and file storage. And the browser then executes that WebAssembly module. They're called modules, usually end with .wasm. Executes that WebAssembly module just like it would any other compiled JavaScript code. It just-in-time evaluates the bytecode that's in there, runs it, tries to do look-ahead, and it can be very efficient because when you execute JavaScript, this part is where you're taking most of your time. This part is really fast, so we can bypass all of that parsing and compiling. So how does Blazor use this? And perhaps more importantly, how does Mono use this? So if we just look at these two blocks, mono.js and mono.wasm, right now, the modern WebAssembly story is that you do need a little bit of JavaScript to essentially bootstrap the process. Because WebAssembly is part of the JavaScript engine, when you load up a WebAssembly module, you have to tell the browser and the JavaScript engine to load that using a little bit of JavaScript that says, load this WebAssembly module and execute it. So the mono.js file is pre-written by the Mono team. It never changes except between releases. And what it essentially does is says, take this mono.wasm and this WebAssembly module and load it and prepare it for execution. This is rather large today. I think on the order of 6-7 megabytes, maybe a little bigger. It contains a full .NET runtime, garbage collector, IL interpreter, reflection, support for dynamic, with some caveats. Essentially, everything you would get in the .NET CLR that you're used to using on the desktop exists inside of this WebAssembly module that they have compiled from the Mono code that exists in C to WebAssembly. So we load that up into the jitter, and it's ready to go. So what can we do with that? Well, we can feed it .NET assemblies. Essentially what you do with a console application. In fact, when you feed it a .NET assembly, you even tell it what method you want to start executing on and what to pass that method, similar to how in a console app you have a main. So what we feed it, and that's what this blazor.js file does, is once blazor.js calls mono.js, bootstraps the mono.net runtime, blazor.js loads in both the core libraries, the BCL for .NET, things like your system namespace, and the assembly that the Blazor tooling has compiled for you. It loads it on top of this mono.wasm runtime, and you're off to the races. Something I want to point out is the app that gets compiled, I mentioned this earlier, it's an assembly. It's not a WebAssembly module. The only piece that exists in WebAssembly in Blazor is the .NET runtime, the Mono runtime. Your Blazor app is just a .NET assembly. It's not compiled to WebAssembly. So you can't run this in isolation outside of the mono WASM module. Now they're working on that, and one scenario that the mono team and the Blazor team have been thinking about is using this setup for development, because it's easy to iterate. We can unload and reload these assemblies almost in real time. But because we have to basically load this into the mono WASM, which is big, like I said, it's 4 to 8 megabytes, somewhere in that range. That's a lot that you've got to carry along with your app, particularly on bad connections. So one thing they're talking about doing is, what if we essentially combined the whole mono.NET runtime with your Blazor app in assembly, with whatever bits of the BCL you're using, statically linked all of that together, and spit out not a assembly, but an actual WebAssembly module that contains your Blazor app, that includes its own integrated side-by-side runtime, IL interpreter, garbage collector, and all the bits of the BCL that your app uses and nothing more. Essentially tree shakes those assemblies into something much smaller that you can deploy as your app. That's sort of the production story that they're trying to work on and get straight. The timing is good because, as you may or may not be aware, the Mono team has also been working with the .NET team to create statically linked and ahead of time compilation for normal .NET apps. So this work kind of goes hand in hand with what they're doing on the .NET desktop and .NET framework to enable ahead of time pre-compilation. Just instead of compiling to a exec, we're compiling to a WebAssembly module. Okay, any questions before we go further? I just want to make sure everyone understands kind of the mechanics here. One thing to, remember I said that the web APIs are going to be important because WebAssembly can't natively talk to these web APIs. Unlike JavaScript code, where these web APIs are basically bound to that JavaScript code at runtime, nothing like that happens when you're running a WebAssembly module. So there are interoperability points, but because WebAssembly kind of executes in this little piece of the jitter, and it's a little bit isolated from the part that does the JavaScript, you have to do interop. You have to basically marshal data back and forth between JavaScript and WebAssembly, because these web APIs are, they're focused on JavaScript. That was the only thing that was using them for years and years and years. So in order to use these from WebAssembly and from your Blazor app, you have to jump through a few hoops. I'm not going to go into that too in depth because they're still kind of working out what that looks like, but basically you have to register kind of like you do with a pinvoke, you have to register that you want to call some bit of JavaScript from your own JavaScript code, and then when you call it in your .NET code, you use a special syntax to say, call this bit of JavaScript that I've pre-registered before mounting my Blazor app in the WebAssembly module. Yes?
So I joined a little late, like just the first 10 minutes of your presentation, but I just have the problem that Blazor is solving is the number of round trips you make to the server, or?
So there are no round trips to the server,
Okay.
Other than to fetch this stuff. Think of this very, very much like Angular or React. This is not a replacement for ASP.NET MVC, Razor Pages. It's not a replacement for any server-side technology. This is purely a client-side thing. So once your browser fetches this stuff from the server, and this can all be static resources, you can serve from a CDN if you want to. Once it fetches all this, everything else happens in your browser. All the .NET code is evaluated in your browser by the Mono WebAssembly module.
Sort of like a desktop app, but it's running inside the browser instead of inside.
Yes, and in fact, I don't think I have a slide on this, but it's worth noting that if you take away the Blazor bits, this whole thing still works. You can still run C# in your browser without Blazor. Blazor just sits on top of the support that lets you run C# in your browser. So some very inventive people are starting to do some interesting things with that. In fact, a guy named Frank Proclarium, who's sort of a friend of the Mono team, has figured out how to render XAML to your browser using the Mono WebAssembly runtime. So you can write XAML code, and it'll stick your basically your XAML GUI in the browser for you, and things like button clicks work, and you can do handlers and write your .NET code to do that app. So yes, it's possibly more like writing a desktop app than you might even imagine. At that point, you can maybe think of the browser as just an operating system or a window manager or something. There's a lot of interesting possibilities here once you look at the piece that sits just underneath Blazor. But tonight we're going to talk about Blazor because that's kind of the most mature use of this technology so far.
Along those lines, a quick question too. So there's a lot of stuff and they're still working out the optimization of this. But in terms of benefits, in general, because you're switching to the JIT level, you would arguably see better performance compared to JavaScript. Apples to apples, like not the whole additional load and loading up DLLs and doing stuff, but you are skipping a couple steps.
So the reason I kind of made a funny face there,
Yeah.
if we were running a C, a Rust, a Go, if we were running a language that was already statically compiled
Yeah.
in WebAssembly, and we were just using WebAssembly as another target for that language, then you're absolutely correct. You'd expect better performance than similarly functioned JavaScript. But that's not what we're doing, because we've essentially built a jitter on top of a jitter. So while the JavaScript jitter is jitting our mono runtime has its own jitter to jit our .NET assembly. And it's got things like garbage collecting. WebAssembly doesn't have a garbage collector. It's a very simple target. So the garbage collector is all happening on top of this, within this piece here. So is it faster? Maybe. It depends on how well the mono WebAssembly runtime performs compared to similar JavaScript code that has to be compiled. You're kind of racing the compiler against our mono jitter. And I don't know which one wins depending on the scenario.
Yeah. A follow-up, and you push this off if you're talking about this later too, but it's like I saw some example code where they do HTTP client, right? They're not going out to that web API stack. They're using a .NET concept for doing
Right, sure.
right? It seems unlikely to me that like the WebAssembly set of language constructs just happens to match up perfectly with the mono set of language constructs. Like, is there a guideline on saying like, yeah, it's in mono, but you really can't do that?
There is no guideline right now. It's buyer beware.
Okay, all right, yeah.
That's something the mono team is actively working on. In fact, most of the work they're doing today is about exposing the APIs that WebAssembly provides, which are sort of like these web APIs. So when we go through here and WebAssembly comes through, WebAssembly actually has to map these through to WebAssembly. And then whatever is running on WebAssembly needs to then map those to its own thing. So, the WebAssembly folks have kind of pinned down, we know what that API service looks like. It's got most of the browser APIs like the DOM. It's just not the same exact APIs that JavaScript uses, but very similar. So what the mono team is doing is basically what they've already done for iOS, for Android. They're in the process of building out support for that WebAssembly API surface area and exposing that as native .NET classes and namespaces to anything running on top of the mono WASM runtime. And you'd bring that in through basically including a namespace that's already pre-linked to your assembly when you're running. So, in that sense, some of it's exposed, some of it's not. I think they've got most of the DOM. Some of the more exotic JavaScript APIs aren't really exposed. So there's really two ways that happens. Mono is trying to expose the full set of WebAssembly APIs, but that's going to take a while. Alternatively, if you're writing something that sits on top of the mono runtime in WASM, you can bypass that piece and basically do what amounts to a p-invoke into JavaScript to call those directly. And then you really are calling this stuff, the JavaScript web APIs. So you can do it either way depending on how quickly you need that functionality.
Thank you.
Yeah?
What would be the typical use case actually? Why would I be choosing Blazor? Or what kind of apps I would be creating?
So right now, the use case is spas. Blazor is a highly componentized application framework for client-side single-page applications is kind of the pitch there. Why would you choose it over something like Angular React? You like .NET? I mean, really, that's kind of the choice here. You know, those other JavaScript-based frameworks are much more mature. Obviously, they're actual products, people using them in production. There's lots of libraries and components written for them. So, you know, in that sense, why would you pick it? You like the language better. The other big advantage that this has down the road, when it does become a product, is this. We can load any .NET assembly. Blazor has support for loading any .NET assembly into your Blazor app, and it'll mount that within the Mono runtime. So do you have business logic that you want to share between the client and the server? Do you have particular libraries that are written in .NET that you want your client to be able to take advantage of? You know, do you want to talk to a microservice straight from your client and not have to go through your web server? All of that you can do in Blazor, or really any .NET app that's running on the Mono runtime, because it's just running those .NET assemblies. It knows how to do that. Now, there are a few caveats there. Some stuff isn't going to work, right? If you try and access the registry, it's going to blow up. If you try and do disk I/O, it's not going to work, because disk I/O is protected by JavaScript. So certain parts of the system namespace and of the BCL, or even of libraries you bring in, aren't going to work. But in that sense, it's very similar to our .NET Standard story today, where we have .NET Standard, and each of the individual runtimes, like .NET Framework, .NET Core, Mono, are adhering to that .NET Standard API service area, and they present the whole thing. But guess what happens if you try and call registry stuff in a .NET Standard library that's running on Linux? You're going to get platform not supported exceptions. Same exact thing on here. If you try and use a library or your own code tries to do anything that wouldn't be supported in this scenario, you'd end up just throwing platform not supported exceptions. Yes?
Is there a way that I can write in my Blazor code something that calls into JavaScript things that have been built before? In other words, like, could I build a Blazor app where one of my pages or one section of my page was built using Vue or React or Angular?
So yes to the former, no to the latter right now. You can register JavaScript functions that Blazor can call. Basically, you have to do it in both ends. You have to write some JavaScript that executes, you know, up in this level that's right in your HTML file that says, hey, Mono runtime, here's a JavaScript function that I may be invoking at some point. Go ahead and make this available. Put it in your dictionary of JavaScript functions that you know about. And then from your .NET code, Blazor exposes a particular static class that you can use that works kind of like a p-invoke. You basically say, invoke the JavaScript function with this name, and you give it a string and whatever parameters you want to pass. And it deals with marshaling the data back and forth. It'll serialize any of the stuff that you're passing as arguments to JSON, and that ends up going into the JavaScript function. So you can call individual JavaScript functions from your Blazor app. Does it interact well with everything on the page? Not at all. It's very clearly designed as a single page application framework right now. More like Angular than like Vue at the moment. A Blazor app can't coexist easily with other JavaScript stuff. For one, it's got its own virtual DOM. So if you try and manipulate the DOM outside of Blazor, bad things will happen. Same reason you can't use Vue and, say, React on the same page. They'll conflict, the virtual DOMs will get all out of sync, and who knows what you're going to get. So I don't know. I hope at some point they do sort of expose a more Vue-like scenario where it's not all single-page apps, and you can just take over a portion of the page like Vue does. I don't know if we'll get there with Blazor, if some other .NET-based WebAssembly framework can do that.
By using Mono, the garbage collector initiates automatically, it does the memory management, or do we need to initiate the garbage collector?
No, good question. No, it works just like the normal desktop CLR. So it'll initiate garbage collection for you in generations when it thinks it needs to. It'll keep watch on the memory. You can initiate it yourself if you want to. If you're used to doing management of the garbage collector and kicking off generations at certain points, you can do that. The memory profile is probably going to be very different than running on a desktop because you're in a sandbox in a sandbox. So right now, until that's better understood, it's probably best to just let the mono runtime handle garbage collection.
So then we have to initiate or we have to include the Blazor and Mono at the initial stage of the app, like when the app is starting, or like.
Yes, although that's done for you. You do, but that's done for you. We'll look at what that code looks like. But Blazor is basically two things. It's this technology. And mainly, this is like the heart of Blazor, this JavaScript file that knows how to talk to the Mono runtime and mount your Blazor app. And it's a Blazor assembly that your Blazor app talks to. But Blazor is also very heavily tooling as part of the Blazor story. When you compile a Blazor app, right now it's using an MS build task that gets pulled into your project through the NuGet package that you include. So creating a Blazor app as a developer isn't all that difficult. But the tooling that works behind the scenes to convert your Razor code that you're writing in your Blazor app into this stuff, and particularly this, is very complicated. And it all ties into MS Build right now. They're looking at building out a CLI, kind of like the other common JavaScript frameworks have, so that you can do it without using MS Build if you want to. But that's very, very early in development. Right now, all their CLI has is an integrated web server, and that's it. They can't compile Blazor apps or anything at the moment. Okay, so let's move on. This is an important point. Blazor does not compile your app to WebAssembly. Blazor sits on top and is more like React Angular Vue. I kind of beat this point to death, but it's a real common misconception right now with the project being early, so I want to make sure everyone understands this. Okay, so let's look at what Blazor does. And I promise we'll get to code soon. I'm going to look at a few different syntax features of Blazor, and then we'll start looking at some code. So first thing, JavaScript interop. A lot goes on behind the scenes to make sure that your click handler in your C# code in Blazor actually gets the click event that bubbles up from the browser. First off, that mono.js file, the bootstrapper, one of the things it does, and one of the reasons this JavaScript file is so big, is that it essentially registers handlers for every event that the browser can throw at it through normal JavaScript APIs. So one of the things it registers is the normal onClick handler for JavaScript. And it kind of registers that at a global level and says, anytime onClick bubbles up, I want to deal with that from my WebAssembly mono code. So when the mono.js file handles those click events, it passes that to the WebAssembly runtime. And this, now we're outside of the normal JavaScript API service area. Mono has now essentially intercepted this onClick event and is now converting it to .NET for us. And then Blazor, the Blazor piece, the Blazor assembly here, says, okay, mono runtime, when you see one of these onClick events, I want to actually handle that, so I'm going to register a handler for that. And then it exposes that handler to your own code, so that now your click handler, or more realistically, what you'll be doing is data binding, your reaction to that event is going to kick off because all of this stuff happened. The moral of the story, though, is that handling events in Blazor is really easy because all of this has happened for you behind the scenes. So rendering. Blazor does maintain a virtual DOM similar to React and Vue. I know Angular is working on one. I don't think Angular uses a virtual DOM yet. Does it use? It uses a shadow DOM, right?
Yeah, and shadow DOM is a different thing.
Yeah.
It's meant for obscuring things from access to the rest of the app for protecting a component.
Yeah, okay.
So
Blazor maintains its own virtual DOM. The way a virtual DOM works, if you're not familiar with how this works in React or Vue, essentially when something changes with the HTML of your page, Blazor changes that internally in a memory model of your page. Nothing happens in the browser yet. Blazor says, okay, you're going to change this HTML, it's going to react this way, you've got a handler that's going to do this, or you've data bound this value, so this is going to change. It changes the page to look like what it should look like. And then it runs a diff against the previous state of the HTML in your page and the new markup of your page. and says, okay, here's the little bits where the markup on this page have changed, where the DOM, and remember, this is all happening in the DOM, not HTML. So it's changing the DOM, it's diffing the DOM from the previous state to the new state. And then once it knows exactly what parts of the DOM have changed, it marshals just that back to the browser and says, change the DOM in these places in this way. That's much more performant because we're not changing the entire page every time something needs to change. If you've data bound, say, the value of a control, and then that value changes, the only thing that makes it back to the browser that the browser has to re-render is just that little bit, the value of that control, and not the whole page. So that's a performance optimization. Really, any modern front-end framework is going to need to do this, because particularly with single-page apps where you're loading like everything into the DOM, re-rendering the whole DOM on every change would be prohibitively expensive. So the Blazor bootstrapper, that's where this other little piece comes in. It has its own rendering callback. And so the your assembly triggers the Blazor assembly, which triggers the JavaScript code in the Blazor bootstrapper, which talks to the web APIs and remaps the DOM for you. So there's kind of 4 levels of abstraction going on behind the scenes for you. Okay, so what do we need to use Blazor today? 0.2 was just released last week. If you want to use it, you need the latest .NET Core 2.1 preview. Blazor is a .NET Core project. It will not run on .NET Framework. It uses the .NET Core SDK, so you need that. You don't have to have Visual Studio. In fact, none of our stuff today is going to use Visual Studio. I'm going to use Visual Studio Code. But if you want IntelliSense, right now the IntelliSense story is only in Visual Studio, and only by getting this special Visual Studio extension. So it's not natively in Visual Studio yet. Essentially what the extension does is it's got some special code that knows this is a Blazor file and provides IntelliSense to Visual Studio for that Blazor file. Eventually, if they make Blazor product, that'll probably get baked into Visual Studio itself and baked into OmniSharp so it works in Visual Studio Code. But right now, if you want IntelliSense, you need VS and this extension. And if you want to quickly create Blazor applications and you want to use the .NET Core templates. Has anyone used .NET Core templates yet? It's really cool. You go .NET new and then something, and all of a sudden you've got a full scaffolded app ready to go. Pull down this NuGet package contains the templates for Blazor. Okay, so what did we get when they iterated to 2.0 to 0.2? And I show this because it shows you how quickly they're moving. My guess is we'll get an 0.3 within the next 3 to 4 weeks, and it'll probably have just as many changes. They introduced first-class support for component libraries. You could do this before, but it wasn't very easy. Now there's a .NET Core template to build a component library that you can use in Blazor. And Blazor understands component libraries versus components that are part of your app. The JavaScript interop story was completely rewritten. Now we've got that whole register invoke set up. Before it was a lot harder to do that. Brand new event handling syntax, brand new data binding syntax, and new conditional attribute rendering, where it will render or not an attribute depending on whether the value of that attribute is null or not. So we're getting there slowly. It doesn't have as many features as your established JavaScript frameworks, right? There's no like your attributes. You can't do like conditional rendering of those right now. There's no sort of native sense of iteration. All of that has to happen in your Razor code using C#. So bit by bit, though, they're building out functionality for stuff that people who use client frameworks are used to. Okay, so if we want to make a Blazor app, and you've downloaded the latest Visual Studio preview and the Blazor Language Services extension, you get a new Blazor application template that you can use. So you just file a new project, create a web project, and make a ASP.NET Core web application, and then Blazor is one of your options. Note that there's 2 Blazor templates. This one that's just called Blazor is your sort of traditional front end, I'm gonna run in my client setup. This one is a little bit special. It creates two projects for you, a Blazor application and a backend ASP.NET MVC Core application for you. This is if you want to make your Blazor app talk to a backend ASP.NET app. And like I said, they're building out this story. Right now, the template basically just gives you both, and it's up to you to figure out what to do with that. In the future, there'll be more and more ties in between the two if you want to use those. Okay, so if we pull down the Blazor templates in .NET Core, this is the syntax to pull down a new template. You say .NET new -i means install, and then you give it the NuGet package that contains the templates you want to install for yourself. So you call this code, this gets you the Blazor templates, and once it's done, you get 3 templates now with the latest version of Blazor. Blazor hosted, which is analogous to that one that gives you both a Blazor client app and a ASP.NET app. Blazor lib, which gives you a standalone Blazor component library, and just plain Blazor, which is a Blazor client app. This is the template and the scenario that we're going to be looking at in our code here in a minute. Okay, so what happens when we actually use that template? So I'm going to call .NET new Blazor -o just says where do I want to output this, and I'm going to place it in a directory called Blazor app1. Then I'm going to change to Blazor app1 and .NET run. What does .NET run do in this case? .NET run executes MS build, which will use the MS build tasks that the Blazor NuGet packages that this template installed for us into our new application. That carries those tasks with it. So .NET run will use MS build. It will compile our Blazor app into assemblies. It will go ahead and copy over the mono.js, the blazor.js, the mono.wasm, all that junk we saw on the left-hand side of the screen earlier. It puts all of that in a directory for you. And then it runs the app and starts embedded web server. So you can start browsing your app right away. And in fact, you know what? Why don't we just go ahead and do that? You can see what a quick Blazor app looks like. Let's see here. Okay, everyone see this? Do I need to zoom this in a little? I'm not even sure how to zoom in.
To the bottom right.
Ah, there we go, thank you. Oh, I can't zoom it in, I can just make it smaller. Oh, that's for the availability. Okay, so you just have to bear with me. In fact, you know what? Why don't we do this?
It's under the system menu, the upper left.
Is it in here?
Upper left. The icon on the upper left side.
You're at your left.
This one?
Somewhere in there, yeah. There's settings. Maybe the one higher where the command CMD is. There, yeah.
Here we go.
Yeah, it's one of those things. Format.
Oh, geez. Okay, this is getting more complicated.
Fonts or colors.
Okay, you know what? Let's bail, I'll open up Visual Studio Code. In fact, I've already got Visual Studio Code open, so let's go ahead and we'll just and this one I do know how to make bigger. Okay, is that better? Everyone can see it now? Okay. You know, let's just stick it right here. Okay, so it's scaffolding thing. We'll look at what it creates in a minute. Right now, I just want to show you what a default Blazor app looks like. Okay, so we're at port 64730. Okay, so did you see where it said loading there for a second? That was when it was loading that mono.wasm file into the WebAssembly piece. The mono.js JavaScript file is what displays that loading icon, and then it waits while we load up the mono runtime into WebAssembly. So this is a sort of the default Blazor template. So you've got a nice little counter here, driven by C# code. We'll look at that in a minute. And something to simulate fetching data. You can see there's a little delay when we bring it up between when the data shows up. So anyway, this is a Blazor app. We're running .NET in the browser right now.
So when you say, so when you're saying localhost, is a request not served by the?
Yeah. So when you do .NET run, you can do .NET build, and that'll build your Blazor app and place everything you need to put on your web server in a particular directory. .NET Run goes a step further and actually launches an embedded web server for you on localhost, and it picks a random ephemeral port from your system. That way, in your development cycle, as you're building it, you do a .NET Run, and then you go and build your app, and it watches the files and rebuilds it for you. And although actually, I should say .NET Run does not have live reload and watching. The Blazor CLI, remember I mentioned earlier, it has a integrated web server that works kind of like running .NET Run. The big difference is it does live reload, which means that as you're changing your Blazor app, the Blazor CLI web server will pick up that you've changed a file, recompile your app in the background, and tell your browser to re-render that page while you're developing. That's the big difference between the two right now. And that's really the only thing the Blazor CLI does at the moment. It'll do more stuff later, like do the templates. Okay.
Is that Edge? Doesn't look like. What browser is that?
Well, I've got Firefox here.
Firefox, okay.
Yeah,
It's Quantum, right?
yeah, it's got a funny blue icon because it's the developer edition.
It's Firefox Quantum?
Yeah,
Okay.
yeah. But Chrome and Edge both have WebAssembly support as well. So what do we do for a new Blazor component library? So Blazor, as a framework, is highly componentized. That if you've used other JavaScript frameworks, that concept shouldn't be unfamiliar because that's kind of the way they're all moving. You basically write components in Blazor and then stack those on top of each other, make child components, compose those components, and that gives you your app. And in fact, each page of that Blazor app we looked at, the counter, the fetch, each of those pages was itself a component. And when you click on a nav in the left nav bar, you're basically telling it load this particular component in the right section of the page, the counter component or the fetch data component. So one of the new things in 0.2 is native support for component libraries. That is, you can now package up these components into a library that you can then stick on NuGet and make reusable if you want, or just to use across your own apps. So to create a new component library, we also have a Blazor lib template that came down when we installed those .NET Core templates. So we're going to make a Blazor lib. We're going to stick that in one folder. Oops. Then we're going to go ahead and do another .NET New to make our Blazor app and stick that in another folder next to our Blazor component library. This is for testing. You don't need to do this part, but if you're developing a component library, you probably want somewhere to put it so that you can see it in the browser. So then, .NET add, and this is just the sort of CLI version of editing your CS_proj file that says, add a reference to Blazor lib1 into my Blazor app1 CS_proj. So now I've got my Blazor app referencing my Blazor component library. And then it's basically the same as before. We go into our Blazor app, we .NET run, and now our component library is available to our Blazor app. And something to note here that's really cool, and this is where this Blazor tooling gets kind of sophisticated. When the Blazor MS build task compiles a Blazor project, it looks at all of the references, both direct and indirect, of that project. Basically anything that would end up in the bin directory if you were building a normal app. And it includes that in the package that gets output for use on your web server, as well as wires up the JavaScript for the Mono runtime that says load these assemblies into the runtime and make them available. So you don't really have to think about it much as a developer. You just reference a .NET assembly, install a NuGet package, whatever you want to do, and that magically becomes available to your client code on the client. That's one of those things that like sounds like, oh yeah, of course that happens. But the tech behind it to make that work is crazy cool, that we can do that. So this is what happens when we load in when we use the template to create a Blazor project file. We end up getting essentially 3 packages and a CLI tool. You don't really need this one, they just install it for you anyway. There's a special kind of NuGet package that basically installs a command line app for you to use within your project. Doesn't end up in the output, has nothing to do with the compilation of your application. It's just a purely development thing. But these packages do get used. So what do we got here? Do we have slides on these? Yeah. So the first one, ASP.NET Core Razor Design. This is the IntelliSense and stuff that talks to the Visual Studio extension that you install if you're using Visual Studio. If we're using VS Code, this doesn't come into play at all, but the template includes it in case you're using Visual Studio. Blazor browser. So what is this? This is the stuff that your application links to at runtime, so that when you compile it, it doesn't say, I don't know what that is. Where's that class coming from? What's this? What's that? This includes the Blazor framework. This is the .NET classes and stuff that your application is going to talk to. And then Blazor build is the MS build tooling that makes all this work. Okay. So Blazor CLI. What can we do with the Blazor CLI? Like I said, not a lot. Right now you say .NET Blazor serve. Any CLI tool that gets deployed as a NuGet package, like this one does, the syntax in .NET Core is .NET, the name of the tool, and then whatever arguments that tool accepts. So serve is the only argument that the Blazor CLI tool accepts right now. And when you do that, it sets this stuff up, says content root path, now listening, application started. It basically does the same thing as .NET Run, with a little bit of extra stuff for live reload.
So the CLI is just an alternative to what we can achieve with Visual Studio 2017 Preview 2, right?
Correct, yeah. .NET Run is roughly equivalent to hitting the play button in Visual Studio. This Blazor CLI is going to get expanded in the future, so it's going to have more Blazor specific functionality. Maybe things like, I'm trying to think what like Vue or React does. Maybe things like creating a single new component within your app. .NET Blazor, new component, my component or something. It'll have some very Blazor specific functionality in there. Whether or not the Visual Studio extension tracks that and adds similar functionality, who knows, probably. Okay, so what do we get? This is the bin folder of a Blazor app after you've built it. You can see we've got a normal bin directory, normal debug directory, normal, this is .NET Core now, so it's going to stick a folder under our debug directory for the target platform. But then we get something interesting. We get this dist folder. Everything in here is what you copy and send or upload to your web server. This is all just static files. If you copy everything out of this directory and upload it to a web server, your Blazor app will work. That's really all there is to it. This is the magic that the MS build tasks do. So what do we get here? Remember I said here's our mono.js file. Here's our mono.asm.js file. In older browsers that don't support WebAssembly, there is a fallback polyfill for WebAssembly called asm.js. It's very slow, You probably don't want to find yourself in the situation of using that with this, because we're already jitting a jitter, et cetera, et cetera. This adds a whole nother layer where we're basically replicating WebAssembly in JavaScript. So it's not great, but it is a fallback for a worst case scenario. So we deploy that as well. Here's our mono WASM module. Here's the mono bootstrapper. Right, so here's our ASM.js bootstrapper. Here's our WebAssembly bootstrapper. Here's the Blazor.js file, which bootstraps all of this and calls the appropriate WASM or ASM mono version, depending on what your browser supports. And a index file that basically contains really just this JavaScript file and says go. But there's one more directory in here that I'll expand on the right, the bin directory. So what does this contain? Why do we have another bin within our bin? So this bin, the underscore bin that's in our distribution, this is the application bin. This is where the Blazor compiler sticks all of the assemblies that are required for our mono runtime. This is our Blazor app, along with everything it depends on. And all of these get loaded into the mono runtime. And you're off to the races at that point. Okay, this is really small. We'll just, let's zoom in on this a little bit. It's not gonna let me, okay. So there's not much here to see. The only thing, what we're looking at here, and I know you can't read it. This is, I opened up .peek, a decompiler, opened up the Blazor app.dll file that the Blazor tooling compiles for you. This is your app. And the thing I wanted to show here that you can kind of see, but maybe not, there's a class called program. Inside of that class called program, there's a static void main string array of args. This should look very familiar if you've ever written a normal console application. Your Blazor app is essentially a console application. And that console application has a single call to something called browser renderer. That is where the Blazor magic lives, inside of this browser renderer method. So this is just basically setting up Blazor here. If you ever want to experiment with the mono WASM runtime on your own outside of Blazor, this is essentially what it is. You write a console app with a program and a main. And whatever code you stick in there is what mono starts executing when you load it into the mono runtime. Okay, so what do we get in our index HTML? I told you it was real short. So we get Bootstrap, some site-specific CSS. Any other CSS you want to include, you put here. Blazor does not have support for inline style sheets like maybe Vue or React components do. Right now, your CSS has to go in the outer HTML file. Here's that loading message that gets replaced. The app tag is special. Blazor looks for that and replaces it when it's fully loaded. And here we're loading our Bootstrap JavaScript, so our Bootstrap components work the way they're supposed to. And then here's the magic. We load up the Blazor Bootstrapper and give some extra custom attributes that the Blazor Bootstrapper will read from the script tag, telling it where our application is located, which assembly, what class and method to load when it loads our assembly into memory, all of the references we need to load, and it expects to find those in that bin directory, that underscore bin directory, and whether or not we want a linker. And that's it. This is the whole web page that gets delivered. Everything else is components, in a true SPA style. Okay, so let's look at Blazor syntax. We're slowly getting to actual Blazor code here. So what do we got for a method? So event handling. To handle a method, we can use one of two different syntaxes. The first looks very much like JavaScript. You just use the normal on whatever handler, on click, on focus, whatever. And then you give it a @ If you've ever used Razor before, @ is kind of the universal, this is my .NET code, not my web or JavaScript code. So you say @ and then the name of a method, a function to handle that. Then you have this functions block. This is from Razor Pages syntax. So if you've only ever used Razor and MVC, this functions bit may not be that familiar to you. It's kind of a carryover from the Razor Pages stuff. Basically, this is taking the place in Razor Pages of what might be in your controller. So you would stick any .NET logic in this functions block, and it ends up as code that gets evaluated and executed. So you create a handler here, match up the names, and you can or don't have to use the event args. Right now, Blazor only exposes a single event args for click handlers. They say they're hoping to expand that in the future. So if you want to handle, say, on focus, you're not going to get arguments with that. You're not going to get information that JavaScript might have, like where it was focused or what the state of the mouse cursor was or the component or whatever, that have an empty arguments list. But for click handlers, you can use arguments or not, depending if you want them. That'll include things like, was it the left mouse button? Was it the right mouse button? Did it double click, single click, etc. And then your .NET C# code just goes right in that handler. Alternatively, you can do an inline handler if you don't want to, if it's a real simple thing, you just want to change a value or something. You can just write a lambda. The @parens is just normal Razor syntax for everything in here is code. And then we're going to write a lambda that says, take the event args and write out to the console, hello world. And this is one of those areas where the Mono team has mapped part of the system namespace to the browser. Console.writeLine will write to your debug console in the browser. This will end up in your DevTools JavaScript console. So data binding. Blazor has two-way data binding. It's a little bit flaky right now, but it works for the most part. The idea here is you use a special syntax attribute called bind, and then just like with the event handling, you just and then the name of the property. It has to be an L value, so it's got to be either a property with a getter and setter, or just a plain old field. You can do that too, but usually you'll have a property with a getter and setter. I generally make this stuff public. The scope of your things in this function block actually does matter if you're writing components, because the HTML code and the .NET code that's in your HTML, like this, is essentially part of the same class as everything in your functions block. So this could be private and it would still work, because we're in the same class. The difference between scope for public and private is that a public property here would be viewable and accessible by other components in Blazor, whereas a private one would be invisible to other components. So a component could potentially, for example, bind to a property of a child component if it were public. And so finally, speaking of binding to components, so let's say we've got a component in counter.css. Right now, components are essentially named by convention. Whatever the name of the Razor file, the CS.html file is, that's the name of your component. So let's say we've got a counter component, and you've got some HTML as part of the component. And we've got a function in here, just a public property called value. And actually, that's not valid, C#. I should not have that sitting there. So now we've got another component in a different area, a different component. And I'm creating my counter here. And I want to bind this to this. In other words, I want whatever is in here that displays or deals with the value property, I want that to react when I change current value in my outer component. So the way that works is it's a special syntax. You do bind and then dash the name of the property of the component that you want to bind to, and then and the name of the property in the outer component you want the value to come from. This to me feels a little clunky. I'm a big fan of Vue, and it seems like they're kind of going for how Vue does data binding a little bit. But to me, this just feels clunky because it's hard to remember, should this be bind-value at current value, or should it be bind-current value at value? keeping those straight for me is a little bit of a challenge. But anyway, that's how it works.
If you want to put something in your getter or your setter, where would you do that? The getter or setter for value.
But if you wanted to do something instead of just set,
Right, if you wanted to validate the value for
oh
it.
sure, yeah, just a normal getter and setter. So you just expand it out and have a get and then a set method.
Okay.
Yeah, this is, within this functions block, it's the C# we all know and love. Latest version of C#. So it's, whatever you can do in C# today, you can do in here. As long as this is an L value, it'll bind. So if you want to do validation, that's fine. It doesn't care. But behind the scenes, basically all it's doing is saying current value equals and then something new. Okay, so remember I said JavaScript interrupt. Here's how it works. Within the JavaScript code, either in an inline script tag in your index.html or in a myapp.js or whatever, you have to basically register the function that you want to call from Blazor. So you say register function. Blazor is a special JavaScript global that handles some things like this. You say my prompt, and then you give it an inline function. And here we're, for example, calling the web API prompt, which shows a prompt to the user. This could be anything you want. You could just proxy to some other piece of JavaScript code you've got, some other Java function. You can call web APIs, you can manipulate the DOM, whatever, it's just JavaScript. Then, this part's optional, but it's handy because just like with p-invokes, the syntax gets a little verbose if you're going to be using this in your code. So we're going to set up a small class called JS functions and add basically a proxy for this prompt thing I registered up here. And the syntax is registered function.invoke, and then the return value goes as your generic parameter, the string name of the thing that you registered, and then this is a optional arguments array. So you pass whatever here that you're expecting here. And this handles marshaling that to and from the JavaScript in your .NET code. Essentially by serializing all of these arguments to JSON and then deserializing them on the JavaScript side. So this part isn't necessary. You could write this piece, this bottom line, you could write out by hand whenever you want to call that function, but that gets really verbose. So then later, if you want to use it, you do like a JS functions.prompt and then whatever message, and that would show a prompt to the user. Okay, there we go. After an hour and 15 minutes or so, we're going to actually look at some running code. We have till 8:30, right? Is that usually when we wrap up? 8:30? Yeah, okay. So what we're going to do here is build up a Blazor app piece by piece. Okay, so what I've done, this has worked well in demos in the past. I have essentially pre-coded all this, so I'm not going to do any live coding to speed things up here a little bit. What we have here is a default Blazor app built from the template, what we just looked at when we did .NET New. In fact, you can see it's been built, so here's my distribution folder, my framework, here's my various assemblies. This is exactly what we looked at earlier. So let's close up my bin folder and actually look at what we got. So what does our Blazor template come with? We have a few pages, a view imports, which tells us where our main layout is. This is straight out of Razor pages. So this is saying our layout is main layout. We've got 3 different pages. And remember, everything is a component. So we're calling it a page. It's really a component. It's just a component that acts like a page. It's a component that is designed to take up the whole browser window. So we've got a counter page, a fetch data page, and an index page. This @page syntax here helps drive the Blazor router. Blazor has an integrated router. It's very simple. All it does is it basically sticks any component with this at page directive and routes to that component when the URL equals whatever you give it. So it is no, this is not a complicated router yet. I'm sure it'll get more complicated as we go. So what does our main layout look like? This component implements iLayout component, which is inside of the Blazor APIs. This is not something you build. This is part of the Blazor APIs that basically says, this is my spa. So this looks like typical Razor. We've got an app body here, which says this is where the stuff that is not my layout goes. This is what I'm going to swap between for my pages when my router sees those routes. And then I've got my other stuff, basically my Chrome, the stuff that goes around my body. In this case, we're just doing a simple bootstrap container. We're sticking a nav menu on the left, and then we've got our body on the right. And then we've got this component called nav menu. This doesn't really do much Blazor-y stuff at all. This is just straight up bootstrap HTML that's got our little nav bar. It does have one special tag helper called navlink. Blazor will eventually offer lots of tag helpers that will help you do special components that are built into Blazor. Right now, the only one it has is navlink. And the purpose of navlink is to basically integrate with the router in Blazor. I don't want to dive into this stuff too much. This is all pretty well documented, so it's easier to learn about. But basically what we've got here is several nav links which say route to these various pages, which in turn load the component that registered that route as in that at page directive at the top. And so when you click on one of these, it says this is the route I want to go to, and stick it in my body, where my app body was as part of my main layout. And then we've got the rest of it. Just like a normal ASP.NET app, we've got a www root, which contains our static assets. And these just get copied over into our dist directory on build. And then we've got our view imports. This is where we put the usings that we want. This then gets compiled in with our Blazor app. You could also put these at the top of your component. Either way, works just like Razor does. If you want a namespace to be in scope, you got to put it either in a view imports or at the top of your component. And then here's our app. You really shouldn't mess with this. This is what sets up our router. So this is, we already looked at what this does. It's got the counter and the fetch data. Our fetch data code here, we're doing some stuff. We've got loading, we've got a table. We're iterating over a forecasts collection and then spinning out table rows based on what we find. So where's that forecast collection coming from? That's down here in our functions. We've got a field called forecasts. To simulate going to a server and getting data, we're doing a HTTP get JSON async. This is going out to a file, getting the JSON, setting it to this forecast thing, because we deserialize it into a weather forecast, and then it's presented to our table. The important thing to note here is the data binding. Take that away. So note that in this for each, we're saying var forecast and forecasts. Initially, forecast is null. There's nothing here until this asynchronous call completes. But because this is in Razor code, the Razor code is sort of implicitly data bound. So once forecast has data, this page will redraw itself and spit out each of these table rows for you. There are limits to how much it infers where it needs to redraw. Things like for each loops work great. If you have really complicated code with like reflection and stuff, it might not pick up that you've redrawn something on the page and it needs to refresh. There's a special syntax to help you do that. Offhand, it's like update state, Blazor app.update state or something. But there's a special syntax you call when you need to update the state of your HTML because you've changed something and it doesn't pick up on it automatically. I expect that piece of it will improve over time. But the cool thing here is that we don't have to explicitly data bind forecasts. It figured out that when forecast changes, the page needs to change.
So they really thought about the more recent JavaScript framework. So that it's somewhat reactive, right? You know, it's
So
kinda like,
yeah,
like they're thinking about Vue and React and Angular in terms of.
well, more sort of low level than that, they're thinking about RX kind of concepts a little bit. You know, where the fields and properties of your component are reactive.
Type of thing.
Yeah.
Yeah, you're watching it.
So like I said, this is still a work in progress. It works pretty well for loops, for like conditionals, but if you go too far off the beaten path, you're going to have to tell it to redraw. Okay, so let's build something, and we'll build this pretty quickly. Let's build a calculator. We're going to go ahead and build a real simple calculator that can add or subtract numbers. So the way we're going to do this is I'm going to go ahead and I've got all of our little stages here as commits. So we will just check out each of these in sequence and see what we get. And because it's easier to view stuff, GitHub has really good diff visualization, so we're just going to visualize the changes here in GitHub for each of these commits. Let's zoom this in a little bit. Too far. Okay. So is this, can you guys see this in the back, or do I need to make it a little bigger?
Yeah.
Okay, good. So, you know, this is a git diff. We're showing what changed. So I'm going to add a page called calculator. I'm going to let it respond to two different routes. Whether it's /calc or /calculator, I want this component to show up as my body either way. And in this calculator, I'm going to have a input, and we're going to make 3 buttons: a plus button, a minus button, and an initially disabled equals button. And then I'm going to have a second input that will mark as read-only. That'll be our answer. And then we're just going to add an additional nav link to our nav menu that routes you to the calculator. So let's see what that looks like. Okay, so here's my calculator. As promised, we've got 2 inputs. I can type whatever I want in here. Nothing is rigged up, so nothing happens. So next step, let's add some data binding. Okay, so what changed? Okay, well, good thing Git is local. So we'll just look at the diffs in here. Hopefully I can make this big enough. Okay, I don't know if I can make this interface bigger. Yeah, I seem to have lost our internet connection here. Okay, so to keep moving, I have a hotspot I can set up, but instead of doing that, we'll just keep moving. This is smaller. Can you guys still see this, or is this harder to see? If it's too hard to see, you can maybe just move your chairs a little closer so you can see the diffs here. But basically what we're doing is I'm going to edit my calculator component. I'm going to add 2 of these bind syntaxes. Bind equals at result, and bind equals at result. So we're going to bind to the same property for both of the inputs, the top and the bottom. And then I'm just going to make a simple, add a function block here. Remember, this is where all my code goes. And I'm just going to make a simple property called result with the getter and the setter. So here's a little mind game. See if you can figure out what's going to happen when I type in the top. Why isn't it changing down here? This is one quirk of Blazor right now. Blazor binds on change, not on, let's see if I'm drawing a blank, the event where you type.
Keyed out.
Yeah. There's actually an even broader one than that. But it doesn't bind when you change a value in an input control. It binds on change, which only happens when you defocus the input. So that result property is only going to get my new value once I remove focus. With the new binding syntax introduced in 0.2, you can actually replicate the way that view or react bind by doing key downs, by just doing that yourself. If you want it to behave like a key down, instead of doing the bind equals at property, you do an on key down equals, and then you can even do an inline lambda that says, take the value of this and stick it in my property. And that would sort of trigger the same thing. But for now, the default binder only works on change, which for input controls means focus. Okay, so what's next? Let's add some event handlers. Okay, so now we're changing a little bit more. We're going to go ahead and, instead of binding to that result property, we're going to make our top input bind to a new property called input. And I'm adding that down here. So we're adding a new property called input, binding to that in the top thing. And then we're going to add a couple handlers. For the plus button, we're going to add a method handler called add. For the subtract button, we're going to add an inline handler, which sets an operation property to subtract. The operation property is just an instance of a enum called oper, which has 3 values, none, add, or subtract. So basically what we're doing in this handler is when I click the minus button, I'm going to set the operation property to the enum value subtract. In my not inline handler, in my method handler, I'm doing the same thing, I'm just doing it as a method. So in my add handler, I'm going to go ahead and set the operation property to the enum value add. So this operation property is going to track my operation, whether I'm adding or subtracting. And then just to kind of show that it's working, I'm going to add a extra little informational output here that says operation, and then notice I'm not binding to anything here. This is just, in fact, when we're looking at this, why don't I just open it? I hope you guys see it a little better. Great, so here's that enum, here's my new properties, and then I'm going to add this. One more thing to notice. This is just outputting this property straight to the screen. I don't have a bind attribute. This isn't in a div. I'm not binding a control. Just like with the for each loop, Razor and Blazor are smart enough to know that when this block of code should change in your view, it's going to go ahead and repaint that. So this is sort of implicitly data bound. Anytime the operation property changes, this bit of the HTML will change to match it. So here's a new operation. If I click plus or minus, you can see it's swapping my my operation control. Okay, next step. So now we're going to do some conditional handling. So I've removed the inline subtract and replace that with a method just like add, because we'll need to do more than an inline thing can handle in a minute. I've also added a little bit more to our informational output to output the values of new properties I'm adding called A and B. I've added some new private fields, A and B. Let's come over here and we'll look at them. All right, so here's my new private fields, A and B. Then in my add and subtract handler, I'm adding in a little bit of extra logic here. I've added a data input method, and only when this returns true do I set my operation. So what does data input do? Data input is going to set either A or B depending on whether I've previously set A. In other words, I've got a, A plus B equals something. So as I put values in that top input, I want the first value to be my left hand, and then the next value I put in needs to be the other thing, my B. So this will set A or B depending. And it also parses those into an int. Notice that my A and B aren't strings, they're ints. One note about the current version of Blazor, binding works really great for any type, as long as that type is a string. Any other type is kind of wonky and you're on your own. So they recommend right now, if you want to bind to say any sort of integer value, any class, whatever else, that you bind it to a string, and then, like you were saying, either have getters and setters that then parse those and put them into the int that you want, or that you handle those as a method or something, which is kind of what we're doing here. We're taking the bound data and then converting it to the properties that we want. And then we're going to go ahead and clear our top input by setting our input property to an empty string, which, because it's two-way data bound, will then set that input to an empty string. In version 0.1, you could have done equals null, which I think would have been more accurate. In 0.2, they broke it. So now you can't two-way data bind. If you have a two-way data bound string and you set it to null after it's set to something, it won't pick that up. It'll pretend like you never changed the value. That's a regression. They've got an open issue for it, and presumably it'll be fixed in 0.3. But that just demonstrates kind of the bleeding edge that we're on here. This is constantly changing. There are bugs. I would not go rush to production with this anytime soon. That said, people are doing really cool things. Did anyone see the, this is Bo, did anyone see the Markdown renderer that someone built last week? They wrote a Blazor app that uses MarkDig, which is a .NET Markdown parser, and stuck that in their Blazor app as a reference, and then had two text areas side by side. And as you type Markdown in the left one, it would render that Markdown to the right pane. And the cool thing about that is it was all in the client. There's no server involved. You're not going back to the server to ask, what does this Markdown look like? The client is using the .NET Markdown rendering library to output HTML from the Markdown, and then they're outputting that HTML directly to the other component in the window. It was a pretty cool sort of experiment someone did. So this is starting to get to the point where we can do some neat things. Okay, so let's see. Let's do 12 plus 10. Okay, I haven't rigged up my equals button yet, so I've got to hit either plus or minus. But you can see it's, as I type these things, it's setting them, because I've got an A, remember my logic was if I have an A, set my B, unless I don't have an A and then set my A, since that's the first one. So now as I type in stuff, it's just gonna add it to B and set my operation. We're also not doing any sort of validation, so nothing's happening. That's because I'm silently screaming in the background. My Razor code is throwing an exception. You just can't see it because I don't have any exception handling.
Yeah, that doesn't just happen to hook up to console and the browser, right?
No, you've got to rig that up. Yeah, I mean, if you really want to do a top-level exception handler, you could put one in your outermost, in that outermost file.
Yes, remember, yeah.
And I can't get my files back. But the one that had the body directive and set up the routing and everything. Yeah, if you surround that whole thing with try catch in a function block, you can catch everything and then do what you want with it. I think there's an open issue for some sort of global exception handler and an event that can call back for that.
Yeah.
But it gets tricky because when you throw an exception, by definition, that means your app is in inconsistent state. So if you're using Blazor to render the exception, Blazor itself is inconsistent because you threw an exception. So it gets to be a little bit like, what do you do there? I'm not sure how they're going to resolve that. There was some talk of putting that outside of Blazor in the JavaScript.
Could you have used try parse? Is that something?
Yes,
because
yes.
that's-
So moving along here. In fact, let's just go, well, no, we'll go along here. We'll just be quick. Okay. So I'm going to do some conditional rendering. I'm going to change my buttons based on whether I have an A or not. Basically, I'm going to turn on the equals button once I get an A. So if I have something plus something, then I can hit equals. What else am I changing? I think that's the only change here. And I'm going to add one more for calculate. That gets called when I hit my equals button. So notice in my equals button now, when I turn it on, I'm going to add a event handler for Glick that we'll call calculate.
Do we have client-side debugging technique?
Pardon?
Client-side debugging, like the developer tool for this part?
No. Nope, at least not yet. So let's do like 10. Now see how my equals button, so now that I have an A, I can't do plus or minus because I'm now going to add these two things. So I'll do 14. Now notice it also cleared it, stuck my B, and I've got my operation is still add because I'm not resetting that with one of the other buttons. Okay, let's get to the fun part, the actual calculation. So what are we going to do in my calculation? I'm not changing my HTML at all this time. Now I'm just going to add some stuff to this calculate method. So let's come down here. I've got my, remember in the previous step, I have my result property. And I added a calculate handler that checks my data input. So when I hit equals, I'm going to take the value, stick it in B, because I already have an A. Then I'm going to go ahead and switch on my operation and set my result, which is just A value, either plus or minus B value. Then, once I've done that, I'm going to clear out everything so I can do it again. I'm going to set my A and B to null, back to their initial state, and we're going to clear the operation so that I can do another operation. And notice that I don't have to say set my input. I just set the result property. The result property is two-way bound. So as soon as I set that to a new value, my result input is going to change to reflect that new value.
So can I put all this function, the programming part, to a separate file?
Absolutely, yeah. You can put it in a, well, you can put it in a separate .NET assembly.
So
Razor Pages doesn't have a concept of a controller where you put your logic. So in a Razor Pages or a Blazor app, your logic is in the component or in a separate assembly that you compile and reference from your component. Either way is fine.
So when a new request comes in, all those data should be shipped to the client side?
Yes, everything in that bin, in that dist. Remember there was the dist folder that included all of the bootstrappers, it included the actual mono runtime and the assemblies that get compiled from your app. That whole dist folder is what you send over to your web server.
Compared to the normal HTML and JavaScript pages, how much load will this add on the first time request?
Well, let's see, we've got a simple calculator app. Come on. Okay, so here's my dist folder. You know, it's got my index page plus everything else. So what's the damage here? About 10 megs. right? So that's pretty big for the simple little one-page app. They're working on that. That's by far the biggest, I think, complaint or production problem with Blazor right now.
But that should get cached, right?
It'll get cached, yeah.
So it only downloads the first.
Correct, yeah. Your browser should cache that because it's not, it's the same static file. Particularly if you set up your web server to make sure you've got good caching headers on there. So yeah, I mean, it's still 10 megs. Some images get that big. I mean, it's not horribly big when you consider that's got basically the entire system namespace, some other stuff, Blazor, the runtime, the garbage collector. But their target is to get that somewhere down around 2 or 3 megs for production use, and possibly even smaller if you statically compile, if they get that ahead of time compilation story. Okay, so now we're going to go ahead and add 2 numbers. Let's add 10 and 20. And it works. And we're reset for another go round. So 1 plus 2. Okay, we've got a working calculator. One thing left to do. A good developer always makes sure they've got error handling. So what are we going to do for error handling? I need a way to display it to the user, so I'm going to add an extra control up here and say if my error property has some stuff in it, then go ahead and just display that in a danger paragraph. And then down here, I need to, right, so this is essentially binding to the error property. I'm just not using bind because it's not a control, but when error changes, my page will change. So now I just need to stick my error in the error property. So I add a new property called error. And then down here where I'm handling my data input and I parse my integers, I'm just going to go ahead and surround this whole thing with a exception handler. And if I get an exception, we'll just set my error property to the message for that exception. And then I want to go ahead and return false here. Why do I want to return false? Because I want to keep the value that caused the problem so the user can continue to work on it. If I return true here, that signals that I want to go ahead and move forward and set A to this value, and then things wouldn't work quite right. Because remember, this returns a Boolean, and in my add and subtract click handlers, I'm checking whether or not data input was successful before I set my operations and my A and B values. And there we go. Right? Anytime I type something that's not an integer, the parse will fail. But then when I get it correct, I'm setting my error message back to null on a correct parse, and the logic continues as it did before. And because I'm saving my state, right, I still have A, I'm still set up for an add operation. So once I get the second one correct, my operation will succeed. So that's kind of Blazor in a nutshell. We've looked at basically all of the functionality in Blazor today. When you get right down to it, it's event handling, data binding, and code. And that's what we've got. So I'm really looking forward to where it's going. It's fun to play with today. You can get started pretty quickly. Just use their template, add a new page, and start playing around, and see what you can build with it.
Is the distribution stored in the browser cache? What happens if I clear my cache?
So they're just normal static files from the web server. So whether it's stored in a browser cache or not is more dependent on the headers that the web server sends to the client than it is on anything Blazor's doing. If the web server is sending cache headers that say cache this for a week, cache this for a month, or even I don't care, then there's a good chance the browser is going to store that in their cache. Depending on the memory available on your system, the hard drive space, some browsers will look at the 6-7 megabyte WASM file and say, oh, that's too big, I'm not going to cache that because I'm low on space. So it's more dependent on the web server and the client environment than it is on Blazor, what gets cached.
So
Caching.
what is the lifetime of the assembly? Like, what I'm trying to get to is it like session bound or something?
No, there's no session.
If you
Yeah.
reload the page, you're saying, which you, in this case, you're not.
Yes.
You're not reloading index, but if you reloaded index.
No, I am. I don't know if you noticed. Every time I changed it, I had to hit the reload button.
Okay.
Yeah.
So if you hit the refresh, so it's reloading those assets or it's got them cached?
I have my Firefox set to clear the cache on reload.
Okay. So it's pulling them back down,
Yeah.
redoing stuff,
Yeah. Although I think it would probably clear it anyway because the assembly, the size would change and the hash would change.
Oh, okay.
So for, and we're using a local web server, which I don't think has cache headers, and probably it might even have a header that tells it don't cache because I know you're doing development.
He's probably thinking if you built an app that you were going to, in the future, you're going to put on a website though, and you're on index and you click a link, is it going to need to pull down the combined, WASM file and all the other stuff?
Yeah, the answer is it depends. And caching can get really, really tricky. Have you ever had the situation where like you're working with, say, a style sheet and you change the style sheet and you're like, why the heck isn't this changing? I know I changed that. Why isn't it cascade? What's going on? And you discover that because the style sheet file name is the same and your web server has the headers that tell the browser to cache it, that you're never pulling the new stuff, that it's using the cached value, and until you clear that cache at the client, you're never going to see the new stuff you added. This is the same exact problem. The same caching problems you have with other static resources like style sheets and JavaScript files.
And do you have all the developer tools that shows you that this static file is coming out of a cache or it is coming from a server? So you can very clearly visibly see in a Chrome dev.
Right, yeah, Firefox and Chrome DevTools are both really, really good at telling you what's going on.
Cache, so at that time you go and say, okay, load from a server, and then it comes from over there.
Yeah, and I imagine that you'd probably have similar challenges if you stick this on a real web server, like IIS, and turn on the cache headers. If you change your app and swap out one of those assemblies, there's a chance you could have cached the older assembly and your app won't get the new stuff. Or even worse, you swap out one of the assemblies and pick up that new one, but not another one that references it. And then you get all kinds of, then you're back in DLL hell with binding problems, except now you're in a web browser instead of, you don't have Fusion log or anything, you're kind of hosed. So you gotta be real careful with caching.
So the router construct here, I think, probably stays on the same page. You're not doing a new page hit, probably, if you go from /calc.
No, this is, Blazor is entirely SPA right now.
Yeah, okay.
You have one HTML page and everything comes from that. You could conceivably add additional HTML pages, just like you can in a SPA. One app model I've seen is sort of the mini spas, where you've got areas of the site and each one is a spa, but they jump between each other. You could certainly do that with Blazor, but that's not really the sort of out-of-the-box model they're promoting right now. Yes?
So due to the multiple JITs with respect to Blazor, performance-wise, how does it compare to Angular or React? Is it slower because it has to JIT multiple times?
So the answer to that is no one really knows right now. The Blazor team has been working on features, so they haven't really put together any sort of app that could be used to benchmark against something else. The only real way to answer that would be to create a comparable app that exercises enough functionality to make it a realistic scenario in both Blazor and one of the other frameworks, and then run it on a variety of different client hardware and browsers and see, do it enough that you get reasonable benchmark statistics and see. Anecdotally, it's probably going to be slower for DOM-heavy apps that do a lot of UI, but probably faster for logic-heavy apps that are running a lot of .NET code. That's just kind of the consensus that people have been sort of realizing as they work with it.
And if it has a lot of .NET code in it, then writing the JavaScript equivalent that you could run inside Angular will be lots of fun.
Right, yeah.
If you had to rewrite
Yeah,
it.
depending on how complicated that equivalent app gets. Yeah, but someone somewhere along the way is going to do that.
But doing that markdown thing,
Yeah.
you know, picking up a markdown component and using it, well, you can't really do that. You can't pick up the .NET markdown component.
Yeah,
and
it
use in
turns
your
out
regular app.
that much to pretty much everyone's surprise earlier this year and last fall when the Mono team kind of got this working for the first time. Before they got the Mono runtime working in WebAssembly, no one knew what that performance profile would look like. There was just so many unknowns. But to everyone's surprise, it's actually pretty darn performant. The Mono jitter in WebAssembly works pretty well, almost at native speed, based on the simple sort of just .NET benchmarks they've done. The slowdown, like I said, is going to be when you start interacting with the browser and marshaling back and forth between the JavaScript engine and the WASM module. Because then you have to marshal all that data, you've got to talk to the DOM. That's going to start slowing things down a bit. Did you have a question? Yeah.
By default, the WebAssembly, is it on all browsers or?
Yes, it's on.
If I want to turn it off, like cookie or something, can I do that?
Yes, well, let's see. It's on all major browsers. I don't have internet anymore. So the answer is yes. Firefox, Chrome, Edge, and Safari all now support WebAssembly. So it's in your browsers on your desktop, it's in your browsers on your handheld, and even if it's not, we still have the ASM.js fallback that will work, it'll just be slower.
Where do you get the information? You seem like you know.
Oh, I'm addicted to GitHub. Some people read Facebook, I read GitHub issues. So yeah, most of the information on this is sort of tied up in the GitHub issues and in looking at the PRs. There is one really good website that I would pull up called learnblazor.com. I think it's .com, it might be .org. It's learn-blazor. One of the TLDs. That's a community-run effort that includes a lot of helpful kind of getting started type content. But mostly it's playing around. Everything that I did here that you saw building up our calculator is mainly just variations on what was already in the initial Blazor template. Just looking at how that works and then figuring out, well, if I glued that this way, here's what would happen. And when you get right down to it, it wasn't that much exotic stuff that's different than Razor and an ASP.NET app, right? We went through a lot. I spent a lot of time talking about under the hood and what's going on and how it fits together, because it's important to understand those things. But from a purely coding standpoint, it's very, very similar to what you're already used to. Really, event handling and data binding and JavaScript interop, if you get into that, are the only things that are different than a normal ASP.NET Razor-based app. Yep, thanks. Hope this was educational.